Hello, this is Math Kimchi, and in this video we'll be going over a double pendulum simulation that I wrote in Java. So let me just start by running it, and this is currently with just one pendulum. And it's a simple pendulum, meaning that the masses are in these pivots, uh, and not in the rods. And right now it's supposed to be what it would look like in real life without any friction or and although rods had no mass, because it's playing at the same time uh, as real time. So uh, this is how it would look with only one pendulum, but I can also make it so there are, let's say, 100 pendulums, and it should still run pretty smoothly. And yeah, you can see how it kind of quickly evolves into chaos, and how even though they all started out really similar, and the only difference was that the starting angle was very slightly off, it still resulted in uh, all of them being vastly different. And this it started out even closer to each other, but yeah, now it's kind of all over the place. And right now it's just displaying everything there is to display, but you can also change it to display, let's see, this is for the pivots, so we can make it display only the root pivot, or yeah, and also the leaves. And if you want to enable multiple things, then you just add it, or you can do display all, or if you don't want to display anything, you can do display none. So let's say we don't want to display any of the rods, then we can say display none for the rods. And yeah, you can see that this is the oh yeah, so this is the root, and all these are the leaves, and it's not displaying anything in between because they'll be in this circle here, and it doesn't really seem like it. But if we did also display the middle ones, this would be the same thing as doing display all, but we would see a circle here. And yeah, you can kind of see that right now, how there's just a ring around the root, because the length is always the same. And so yeah, and you can see from this that it's kind of all messed up, because all of them started out at the almost the same energy, and it should be constant, but it's not. And I'm pretty sure it's because the time factor is too big. But if we were to make this something like 0.5 or even smaller than that, then it should be much better. Yeah, you can see. Hmm, actually, if we did this and didn't do any of the display stuff, yeah, if we didn't update the display, it should run much faster. And you can kind of see how the total energy, and this is for each individual um, rod, but yeah, you can see that the total energy is like it's kind of decreasing, but at a very slow rate. Uh, so yeah, I'm assuming that even though it's supposed to be constant, it's slowly decreasing because I guess just like a rounding error. But there is also a chance that I messed up one of the equations, but uh, to me it looks pretty normal when we run it in like real time. And let me display everything. Or maybe if I only displayed the leaf for the rods. Oh, and for the rods, the root doesn't actually mean anything. But yeah, if you like focus on one of them, it looks pretty normal. So I'm assuming that it's just an error because of the time. And yeah, this looks pretty cool. That's weird. It, it kind of looks like as time is going on, it's almost like there is friction, but I don't know, it's probably fine. And yeah, previously I was able to make this rainbow colored, but then I changed everything to make it more, I don't know, so it made more sense. Uh, and also so I could start to like save the simulation at a certain time frame. Uh, and I was able to do that before as well, but I was as a image. Uh, and the reason why I wanted to change that was because if I was able to save each point as not an image but just all the angles and their velocities and acceleration, then I'll be able to load it from any point that I stopped it at and play it. And also, I could change the visuals, but when I could make it like rainbow colored, Uh, this is what happened every frame, and I guess it looks pretty cool. So let me run that. Hmm. Hmm. Let's see. What's wrong? Oh, I changed the name. Hmm. Yeah, but you can see how even though they all started out at a very similar position, now they quickly end up all over the place. And yeah, originally a lot of the similar colors started at a similar position, and you can still see that. For example, there's like this blue line, and I guess those stay similar for longer than the other ones, which is pretty cool. But yeah, I'm mostly kind of just showing this uh, to show this off. But I guess I should also explain some of the code in case uh, someone wants to change it for themselves. So basically, this is the main runner, and it calls real time simulation, and uh, yeah, real time simulation is where basically everything happens. So when you start it, it first creates. Let's see. Yeah, it just saves all of the variables, and yeah, some of them are for the simulation, but also for the display as well. And the time factor is like uh, how fast the time is. So the smaller it is, the slower it looks, and the higher time factor is, the the faster the simulation is relative to a real life time. And is real time basically makes it so if this is true, then it's based off of how much time has passed in between the frames. But if it's false, then it's just the D time is always the same, and it's going to be time factor. And should save. If it's true, then it'll get every frame will be saved as a PNG in the images, but it will also get rewritten if you run it again. And so this is why I have this thing, uh, because it always saves to images, so I just rename the file or the folder. And physical system is this, and currently there's only one subclass of single base pivot pendulum system, which is a long name, but yeah, this. And all it does is it creates a base pivot and creates a variable amount of rods coming out of the base children, or the base pivot. And yeah, if you just call it without any parameters, it's gonna call it with these. And yeah, you can also set the gravity, the number of pendulums, start theta. So in this case it's 2.3, which is like let me, yeah, so this would be 2.3. And right now the difference per is really small, so it almost looks the same. But if I were to make it, let's say there were only 5, and difference per was pi over 10, and again, yeah, so it's just based off of radians. And difference per is how much the next, yeah, it's just the offset. And let me just make it something really small again. And yeah, num frames to do is just how many frames it does. And if you want it to go on infinitely, make it -1. And yeah, real-time simulation also takes in a displayer, and this is the thing that calls the standard draw, and it displays everything. And you can mess with the display settings, but I'm probably gonna work on this, mostly the displayer, after I upload this video. And yeah, I guess I can explain some of the math, even though I mostly just copied it. So all of these are the constants, and from here to here are all the constants for theta acceleration, and here are the things for Ke and Pe, so kinetic and potential energy, but they they don't actually affect the program, I guess. I only use it for printing purposes. So yeah, this is pretty much unnecessary. And yeah, update theta acceleration recursively. This is what um, this is the main math, and all the other math is pretty like simple. You update the theta based off of the velocity and also the difference in time, and you update the velocity based off the time, and or based off the acceleration and time. And I say recur after a lot of my methods, and it just means that you only have to call it for the base pivot, because afterwards it's going to call it for all of its children, I guess. And yeah, and like the only other math that it goes into this is for printing. Yeah, but it's just for sine and cosine, and it might make more sense to make this negative, but I flipped around the y scale, so a greater y actually means it's lower, and x is just normal. And I guess another thing with math is the display procedures, but that math doesn't really have to do with the simulation. It's mostly, yeah, it's just for displaying, and it's like, it's mostly bit manipulation or the math, but yeah, since this is in binary, and this is always going to be like a power of 2, if like the digit that this is 1 for is also 1 here, then this doesn't become 0, and it's going to become this. So yeah, that's all that is. And I would like to extend this to make it more than just for a double rod, but I think my understanding of physics right now should, I guess, improve before I try to do that. So yeah, if I ever make a video on that, it's gonna be a while later. But yeah, this is just something cool I made, and I wanted to share it. But this will be on my GitHub or in the description for this video, and thanks for watching.